Okay, example 4. An ideal gas is contained in a cylinder by a frictionless tight piston. So the cylinder is surrounded by an insulation to prevent loss of heat. So there is no loss of heat. Initially, the volume of the gas is 2.9. Its pressure is this, and its temperature is this one. So calculate the number of the moles for the gas in the cylinder. So what is given? Given is the volume, then 4 cubic meter, and then we have the pressure, initial pressure, and then the temperature. Okay, so we can use the ideal gas equation to find the number of moles. Sorry, RT. So you should get the number of moles to be equal to 1.16 10 negative 2 moles. Okay, and then question B, we have to calculate, the gas is then compressed to 2.9 negative 5 cubic meter. Then the temperature rises to 790 Kelvin. So we have to calculate the pressure of the gas after this compression. So we have to find P2 lah kan. Okay. So again, this one we can use the ideal gas equation lah. Okay, sebab kita ada, we have to find P2, V2 given, T2 is given as well. So we can just use this equation. So the pressure is equal to 2.63 times 10 to the power of 6 Pascal. Okay, and then calculate the work done on the gas during the compression. The work done on the gas during the compression is 91 joule. So compression, if it is compressed, gas is compressed, it is gonna be negative 91 joule. Then we have to calculate the change in internal energy. Okay, so since the cylinder is insulated, there is no heat loss, so Q is equal to 0 kan? So from here we can use the first law of thermodynamics, where this is equal to 0, delta U plus W. So delta U is equal to negative W. So this is just negative 91. It will be equal to 91 joule. So the the energy in the system increases lah. Okay, and then explain why a rise in the temperature takes place during the compression. So this is an adiabatic process, right? So when the gas is compressed, adiabatically, it does negative work. So work will be negative. Okay, so when work is negative, we can see that the change in internal energy will be equal to negative W. So the internal energy of the gas increases. So it provides the necessary energy to do work, since the internal energy is proportional to the absolute temperature. When the internal energy increases, there will be a rise in temperature as well. Okay, so that is why there is a rise in the temperature as it undergoes compression. Okay, so that is the solution for example number 4.